Handymax bulk carrier. Grain bulk carrier and loading apparatus. Seattle 2010. A bulk carrier, bulk freighter, or colloquially, bulker is a merchant ship specially designed to transport unpackaged bulk cargo, such as grains, coal, ore, and cement, in its cargo holds. Since the first specialized bulk carrier was built in 1852, economic forces have led to continued development of these ships, resulting in increased size and sophistication. Today's bulk carriers are specially designed to maximize capacity, safety, efficiency, and durability. Today, bulk carriers make up 21% of the world's merchant fleets and range in size from single-hold mini bulk carriers to mammoth ore ships able to carry 400,000 metric tons of deadweight (DWT). A number of specialized designs exist. Some can unload their own cargo. Some depend on port facilities for unloading, and some even package the cargo as it is loaded. Over half of all bulk carriers have Greek, Japanese, or Chinese owners, and more than a quarter are registered in Panama. South Korea is the largest single builder of bulk carriers, and 82% of these ships were built in Asia. On bulk carriers, crew are involved in operation management and maintenance of the vessel, taking care of safety, navigation, maintenance, and cargo care, in accordance with international maritime legislation. Cargo loading operations vary in complexity, and loading and discharging of cargo can take several days. Bulk carriers can be gearless, dependent upon terminal equipment, or geared, having cranes integral to the vessel. Crews can range in size from 3 people on the smallest ships to over 30 on the largest. Bulk cargo can be very dense, corrosive, or abrasive. This can present safety problems, cargo shifting, spontaneous combustion, and cargo saturation can threaten a ship. The use of ships that are old and have corrosion problems has been linked to a spate of bulk carrier sinkings in the 1990s, as have the bulk carriers' large hatchways. While important for efficient cargo handling, these allow the entry of large volumes of water in storms or if a ship is endangered by sinking. New international regulations have since been introduced to improve ship design and inspection, and to streamline the process of a crew's abandoning ship. Cross-section of a typical bulk carrier. 1. Cargo hold 2. Hatch cover 3. Upper hopper tank for water ballast or oil 4. Double bottom 5. Lower hopper tank, for water ballast. The term bulk carrier has been defined in varying ways. As of 1999, the International Convention for the Safety of Life at Sea defines a bulk carrier as a ship constructed with a single deck, topside tanks and hopper side tanks in cargo spaces and intended to primarily carry dry cargo in bulk, an ore carrier, or a combination carrier. 2. Most classification societies use a broader definition, by which a bulk carrier is any ship that carries dry unpackaged goods. 3 multipurpose cargo ships can carry bulk cargo, but can also carry other cargoes and are not specifically designed for bulk carriage. The term dry bulk carrier is used to distinguish bulk carriers from bulk liquid carriers such as oil, chemical, or liquefied petroleum gas carriers. Very small bulk carriers are almost indistinguishable from general cargo ships, and they are often classified based more on the ship's use than its design. A number of abbreviations are used to describe bulk carriers. OBO describes a bulk carrier that carries a combination of ore, bulk, and oil, and O/O is used for combination oil and ore carriers for the terms VLOC, VLBC, ULOC, and ULBC for very large and ultra-large ore and bulk carriers were adapted from the supertanker designations very large crude carrier and ultra-large crude carrier. 5. History edit. Before specialized bulk carriers were developed, shippers had 2 methods to move bulk goods by ship. In the first method, longshoremen loaded the cargo into sacks, stacked the sacks onto pallets, and put the pallets into the cargo hold with a crane. 6. The second method required the shipper to charter an entire ship and spend time and money to build plywood bins into the hold. 7. Then, to guide the cargo through the small hatches, wooden feeders and shifting boards had to be constructed. 7. These methods were slow and labor-intensive. As with the container ship, the problem of efficient loading and unloading has driven the evolution of the bulk carrier citation needed. Specialized bulk carriers began to appear as steam-powered ships became more popular. 6. The first steamship recognized as a bulk carrier was the British coal carrier SS John Bowes in 1852-89. She featured a metal hull, a steam engine, and a ballasting system which used seawater instead of sandbags. 8. These features helped her succeed in the competitive British coal market. 8. The first self-unloader was the lake freighter Hennepin in 1902 on the Great Lakes. This greatly decreased the unloading time of bulk carriers by using conveyor belt to move the cargo. 10. The first bulk carriers with diesel propulsion began to appear in 1911-89. Before World War II, the international shipping demand for bulk products was low, about 25 million tons for metal ores 11-12, and most of this trade was coastal. 13. However, on the Great Lakes, bulk carriers hauled vast amounts of ore from the northern mines to the steel mills. In 1929, 73 million tons of iron ore was transported on the lakes, and an almost equal amount of coal, limestone, and other products were also moved. 14. Two defining characteristics of bulk carriers were already emerging: the double bottom, which was adopted in 1898, and the triangular structure of the ballast tanks, which was introduced in 1905-8. After World War II, an international bulk trade began to develop among industrialized nations, particularly between the European countries, the United States and Japan. 11. Due to the economics of this trade, ocean bulk carriers became larger and more specialized. 12-15. In this period, Great Lakes freighters increased in size, to maximize economies of scale, and self-unloaders became more common to cut turnaround time. The 1,000-footers of the Great Lakes fleets, built in the 1970s, were among the longest ships afloat, and in 1979, a record 214 million ton of bulk cargo were moved on the Great Lakes. 16. Categories edit. Size categories edit. Major bulk carrier size categories. Name. Size in DWT 17. Ships 18. Traffic 19. New. Price 20. used. Price 21. Handysize 10,000 to 35,000. 34%. 18%. $25 million. $20 million. Handymax 35,000 to 59,000. 37%. Panamax 60,000 to 80,000. 19%. 20%. $35 million. $25 million. Capesize 80,000 and over. 10%. 62%. $58 million. $54 million. Post-deepening of the Suez Canal, a Capesize bulk carrier approaches the Egyptian-Japanese Friendship Bridge. Bulk carriers are segregated into 6 major size categories: small, handysize, handymax, panamax, capesize, and very large. 22 very large bulk and ore carriers fall into the capesize category but are often considered separately. Categories as per regions. Edit. Categories occur in regional trade, such as Kamsar Max 23, Seaway Max, Setuch Max, Dunkirk Max, and Newcastle Max also appear in regional trade. 22. Kamsar Max, maximum length overall 229 meters, refers to a new type of ships, larger than Panamax, that are suitable for berthing at the port of Kamsar, Republic of Guinea, where the major loading terminal of bauxite is restricted to vessels not more than 229 meters. 24. Newcastle Max, maximum beam 50 meters, and maximum length overall of 300 meters, refers to the largest vessel able to enter the port of Newcastle, Australia at about 185,000 dwt. 25. Setuch Max, about 203,000 dwt, being the largest vessels able to navigate the Setuki Sea, Japan. Seaway Max, LOA 226 m max / 7.92 m draft, refers to the largest vessel that can pass through the canal locks of the St. Lawrence Seaway, Great Lakes, Canada. 26. Malacca Max, LOA 330 m / 20 m draft / 300,000 dwt, refers to the largest vessel that can pass through the Straits of Malacca. Dunkirk Max, maximum allowable beam equals 45 m / LOA 289 m max, 175,000 dwt approximate, for the Eastern Harbour Lock in the port of Dunkirk, France. Many bulk carriers are prevalent in the category of small vessels with a capacity of under 10,000 dwt. Many bulk carriers carry from 500 to 2,500 tons, have a single hold, and are designed for river transport. They are often built to be able to pass under bridges and have small crews of 3 to 8 people. Handysize and handymax ships are general purpose in nature. 3. These two segments represent 71% of all bulk carriers over 10,000 dwt and also have the highest rate of growth. 27. This is partly due to new regulations coming into effect which put greater constraints on the building of larger vessels. 27. Handymax ships are typically 150-200 m in length and 52,000-58,000 dwt with 5 cargo holds and 4 cranes. 3. These ships are also general purpose in nature. 3. The size of a Panamax vessel is limited by the Panama Canal's locked chambers, which can accommodate ships with a beam of up to 32.31 m, a length overall of up to 294.13 m, and a draft of up to 12.04 m28. Cape-size ships are too large to traverse the Panama Canal and must round Cape Horn to travel between the Pacific and Atlantic Oceans. Earlier, Cape-size ships could not traverse the Suez and needed to go around the Cape of Good Hope. Recent deepening of the Suez Canal to 66 feet, 20 m, permits most Cape-size ships to pass through at 29. Cape-size bulk carriers are specialized. 93% of their cargo is iron ore and coal. Some ships on the Great Lakes waterway exceed Panamax dimensions, but they are limited to use on the Great Lakes as they cannot pass through the smaller St. Lawrence Seaway to the ocean. Very large ore carriers and very large bulk carriers are a subset of the Cape-size category reserved for vessels over 200,000 dwt. 22 carriers of this size are almost always designed to carry iron ore. 22. General types. Edit. General bulk carrier types. Illustration. Description. Geared bulk carriers are typically in the handysize to handymax size range, although there are a small number of geared Panamax vessels. Like all bulk carriers, they feature a series of holds covered by prominent hatch covers. They have cranes, derricks or conveyors that allow them to load or discharge cargo in ports without shore-based equipment. This gives geared bulk carriers flexibility in the cargoes they can carry and the routes they can travel. Photo: a typical geared handysize bulk carrier. Combined carriers are designed to transport both liquid and dry bulk cargoes. If both are carried simultaneously, they are segregated in separate holds and tanks. Combined carriers require special design and are expensive. They were prevalent in the 1970s, but their numbers have dwindled since 1990. Photo: the oil pipeline and dry bulk hold aboard Maya. Gearless carriers are bulk carriers without cranes or conveyors. These ships depend on shore-based equipment at their ports of call for loading and discharging. They range across all sizes. The larger bulk carriers, VLOCs, can only dock at the largest ports. Some of these are designed with a single port-to-port trade in mind. The use of gearless bulk carriers avoids the costs of installing, operating, and maintaining cranes. Photo: Berga Athen, a 225,000-ton gearless bulk carrier. Self-dischargers are bulk carriers with conveyor belts, or with the use of an excavator that is fitted on a traverse running over the vessel's entire hatch, and that is able to move sideways as well. This allows them to discharge their cargo quickly and efficiently. Photo: John B. Aird, a self-discharging lake freighter. Lakers are the bulk carriers prominent on the Great Lakes, often identifiable by having a forward house that helps in transiting locks. Operating in fresh water, these ships suffer much less corrosion damage and have a much longer lifespan than saltwater ships. 30 As of 2005, there were 98 Lakers of 10,000 dwt or over 31. Photo: Edward L. Ryerson, a Great Lakes bulk carrier. Bibbo or bulk in, bags out bulk carriers are equipped to bag cargo as it is unloaded. CHL Innovator, shown in the photo, is a Bibbo bulk carrier. In 1 hour, this ship can unload 300 tons of bulk sugar and package it into 50 kg sacks. 32. Fleet characteristics. Edit. Growth of bulk carrier deadweight tonnage in green and percentage of bulk carriers to the entire fleet in red, from 1977 to 1999. 33. The world's bulk transport has reached immense proportions. In 2005, 1.7 billion metric tons of coal, iron ore, grain, bauxite, and phosphate was transported by ship. 34 today. The world's bulk carrier fleet includes 6,225 ships of over 10,000 dwt, and represent 40% of all ships in terms of tonnage and 39.4% in terms of vessels. 31 including smaller ships. Bulk carriers have a total combined capacity of almost 346 million dwt. 35 combined carriers are a very small portion of the fleet, representing less than 3% of this capacity. 35 The lake freighters of the Great Lakes, with 98 ships of 3.2 million total dwt, despite forming a small fraction of the total fleet by tonnage and only operating 10 months a year, carried a tenth of the world's bulk cargo because of the short trip distance and fast turnarounds. 31-36. As of 2005, the average bulk carrier was just over 13 years old. 37 About 41% of all bulk carriers were less than 10 years old, 33% were over 20 years old, and the remaining 26% were between 10 and 20 years of age. 37 All of the 98 bulk carriers registered in the Great Lakes trade are over 20 years old, and the oldest still sailing in 2009 was 106 years old. 38. Bulk carriers by flag state. 39. Source data. Flag states edit. As of 2005, the United States Maritime Administration counted 6,225 bulk carriers of 10,000 dwt or greater worldwide. 40 more bulk carriers are registered in Panama, with 1,703 ships, more than any four other flag states combined. 40 in terms of the number of bulk carriers registered. The top 5 flag states also include Hong Kong with 492 ships, Malta, 435, Cyprus, 373, and China, 371. 40 Panama also dominates bulk carrier registration in terms of deadweight tonnage. Positions 2 through 5 are held by Hong Kong, Greece, Malta, and Cyprus. 40. Largest fleets edit. Greece, Japan, and China are the top 3 owners of bulk carriers, with 1,326, 1,041, and 979 vessels respectively. 41 These 3 nations account for over 53% of the world's fleet. 41. Several companies have large private bulk carrier fleets. The multinational company Gearbulk Holding Limited has over 70 bulk carriers. 42 The FedNav Group in Canada operates a fleet of over 80 bulk carriers, including 2 designed to work in Arctic ice. 43 Croatia's Atlantska Plovidba DD has a fleet of 14 bulk carriers. 44 The H. Vogtman Group in Hamburg, Germany operates a fleet of 19 bulk carriers. 45 Portline in Portugal owns 10 bulk carriers. 46 Dampskibsselskabet in Denmark and Elcano in Spain also own notable bulk carrier fleets. 47. Other companies specialize in many bulk carrier operations. England's Stevenson Clark Shipping Limited owns a fleet of 8 mini bulk carriers and 5 small handysize bulk carriers. 48 And Corn Ships Management and Agency Incorporated in Turkey owns a fleet of 7 mini bulk carriers. 49. Builders edit. Asian companies dominate the construction of bulk carriers. Of the world's 6,225 bulk carriers, almost 62% were built in Japan, 50 by shipyards such as Oshima Shipbuilding and Sanwoi's Hishino Maisho. 3 South Korea, with notable shipyards Daewoo and Hyundai Heavy Industries. 3 ranks second among builders, with 643 ships. The People's Republic of China, with large shipyards such as Dalian, Shanxi, and Shanghai Weijiao, ranked third, with 509 ships. 50 Taiwan, with shipyards such as China Shipbuilding Corporation 3 ranked fourth, accounting for 129 ships. 50 shipyards in these top 4 countries built over 82% of the bulk carriers afloat. 50. Freight charges. Edit. Average time charter rates for bulk carriers. Several factors affect the cost to move a bulk cargo by ship. The bulk freight market is very volatile, and it fluctuates, along with the type of cargo, the ship's size, and the route traveled all affect the final price. Moving a Capesize load of coal from South America to Europe cost anywhere from $15 to $25 per ton in 2005. 51 Hauling a Panamax-sized load of aggregate materials from the Gulf of Mexico to Japan that year could cost as little as $40 per ton to as much as $70 per ton. 51. Some shippers choose instead to charter a ship, paying a daily rate instead of a set price per ton. 51 In 2005, the average daily rate for a Handymax ship varied between $18,000 $30,000. 51 A Panamax ship could be chartered for $20,000 $50,000 per day, and a Capesize for $40,000 $70,000 per day. 51. Ship breaking. Edit. Main article, Ship breaking. Generally, ships are removed from the fleet by going through a process known as ship breaking or scrapping. 52 Ship owners and buyers negotiate scrap prices based on factors such as the ship's empty weight, called light ton displacement or LDT, and prices in the scrap metal market. 53 In 1998, almost 700 ships were scrapped in places like Alang, India, and Chittagong, Bangladesh. 52 This is often done by beaching the ship on open sand, then cutting it apart by hand with gas torches, a dangerous operation that results in injuries and fatalities, as well as exposure to toxic materials such as asbestos, lead, and various chemicals. 54 55 56 500,000 deadweight tons worth of bulk carriers were scrapped in 2004, accounting for 4.7% of the year's scrapping. 51 That year, bulk carriers fetched particularly high scrap prices, between $340 and $350 per LDT. 51. Operation. Edit. Crew. Edit. Typical bulk carrier crew: Captain/Master, Deck, Department, Engine, Department, Stewards, Department, 1 Chief Mate, 1 Second Mate, 1 Third Mate, 1 Boatswain, 2 6 Able Seamen, 02 Ordinary Seamen, 1 Chief Engineer, 1 Second Engineer, 1 Third Engineer, 1 2 Fourth Engineers, 02 Motormen, 1 3 Oilers, 03 Greasers, 1 3 Wipers, 1 Chief Steward, 1 Chief Cook, 1 Steward's Assistant. The crew on a bulk carrier typically consists of 20 to 30 people, though smaller ships can be handled by 8. The crew includes the captain or master, the deck department, the engine department, and the steward's department. The practice of taking passengers aboard cargo ships, once almost universal, is very rare today and almost non-existent on bulk carriers. 57. During the 1990s, bulk carriers were involved in an alarming number of shipwrecks. This led ship owners to commission a study seeking to explain the effect of various factors on the crew's effectiveness and competence. 58 The study showed that crew performance aboard bulk carriers was the lowest of all groups studied. 58 Among bulk carrier crews, the best performance was found aboard younger and larger ships. 58 Crews on better maintained ships performed better, as did crews on ships where fewer languages were spoken. 58 Fewer deck officers are employed on bulk carriers than on similarly sized ships of other types. 58 A mini bulk carrier carries 2 to 3 deck officers, while larger handysize and capesize bulk carriers carry 4. 58 Liquid natural gas tankers of the same size have an additional deck officer and unlicensed mariner. 58 Voyages Edit. A bulk carrier's voyages are determined by market forces. Routes and cargoes often vary. A ship may engage in the grain trade during the harvest season and later move on to carry other cargoes or work on a different route. Aboard a coastal carrier in the tramp trade, the crew will often not know the next port of call until the cargo is fully loaded. Because bulk cargo is so difficult to discharge, bulk carriers spend more time in port than other ships. A study of mini bulk carriers found that it takes, on average, twice as much time to unload a ship as it does to load it. 58 A mini bulk carrier spends 55 hours at a time in port, compared to 35 hours for a lumber carrier of similar size. 58 This time in port increases to 74 hours for Handymax and 120 hours for Panamax vessels. 58 Compared with the 12-hour turnarounds common for container ships, 15-hour turnarounds for car carriers, and 26-hour turnarounds for large tankers, bulk carrier crews have more opportunities to spend time ashore. 58 Loading and unloading edit. Loading and unloading a bulk carrier is time-consuming and dangerous. The process is planned by the ship's chief mate under the direct and continued supervision of ship's captain. International regulations require that the captain and terminal master agree on a detailed plan before operations begin. 59 Deck officers and stevedores oversee the operations. Occasionally loading errors are made that cause a ship to capsize or break in half at the pier. 60 The loading method used depends on both the cargo and the equipment available on the ship and on the dock. In the least advanced ports, cargo can be loaded with shovels or bags poured from the hatch cover. This system is being replaced with faster, less labor-intensive methods. 61 Double articulation cranes, which can load at a rate of 1,000 tons per hour, represent a widely used method. 61 And the use of shore-based gantry cranes, reaching 2,000 tons per hour, is growing. 61 A crane's discharge rate is limited by the bucket's capacity, from 6 to 40 tons, and by the speed at which the crane can take a load, deposit it at the terminal and return to take the next. For modern gantry cranes, the total time of the grab deposit return cycle is about 50 seconds. 3 Conveyor belts offer a very efficient method of loading, with standard loading rates varying between 100 and 700 tons per hour, although the most advanced ports can offer rates of 16,000 tons per hour. 61-62 Startup and shutdown procedures with conveyor belts, though, are complicated and require time to carry out. 62 Self-discharging ships use conveyor belts with load rates of around 1,000 tons per hour. 61 Once the cargo is discharged, the crew begins to clean the holds. This is particularly important if the next cargo is of a different type. 63 The immense size of cargo holds and the tendency of cargoes to be physically irritating add to the difficulty of cleaning the holds. When the holds are clean, the process of loading begins. It is crucial to keep the cargo level during loading in order to maintain stability. 7. As the hold is filled, machines such as excavators and bulldozers are often used to keep the cargo in check. Leveling is particularly important when the hold is only partly full, since cargo is more likely to shift. 64 Extra precautions are taken, such as adding longitudinal divisions and securing wood atop the cargo. 6. If a hold is full, a technique called tomming is used. 7. Which involves digging out a 6 feet, 2 hole below the hatch cover and filling it with bagged cargo or weights. 7. A typical bulk carrier offload. 1. A bulldozer is loaded into the hold. 2. The bulldozer pushes cargo to the center of the hold. 3. The gantry crane picks up the cargo. 4. The gantry crane removes the cargo from the ship. 5. The gantry crane moves the cargo to a bin on the pier. Photos courtesy of Danny Cornelissen of portpictures.nl. Architecture edit. Examples of bulk carrier architectural plans. Line plan of a 1990 Capesize ore carrier. Typical midship section of a bulk carrier with a single hull and double bottom. A bulk carrier's design is largely defined by the cargo it will carry. The cargo's density, also known as its stowage factor, is the key factor. Densities for common bulk cargoes vary from 0.6 tons per cubic meter for light grains to 3 tons per cubic meter for iron ore. 3. The overall cargo weight is the limiting factor in the design of an ore carrier, since the cargo is so dense. Coal carriers, on the other hand, are limited by overall volume, since most bulk carriers can be completely filled with coal before reaching their maximum draft. 3. For a given tonnage, the second factor which governs the ship's dimensions is the size of the ports and waterways it will travel to. For example, a vessel that will pass the Panama Canal will be limited in its beam and draft. For most designs, the ratio of length to width ranges between 5 and 7, with an average of 6.23. The ratio of length to height will be between 11 and 12. 3. Machinery edit. The engine room on a bulk carrier is usually near the stern, under the superstructure. Larger bulk carriers, from Handymax up, usually have a single 2-stroke low-speed crosshead diesel engine directly coupled to a fixed-pitch propeller. Electricity is produced by auxiliary generators and/or an alternator coupled to the propeller shaft. On the smaller bulk carriers, 1 or 2 4-stroke diesels are used to turn either a fixed or controllable pitch propeller via a reduction gearbox, which may also incorporate an output for an alternator. 3. The average designed ship speed for bulk carriers of Handysize and above is 13.5-15 knots, 25.0-27.8 km/h, 15.5-17.3 mph. 22. The propeller speed is relatively low, at about 90 revolutions per minute, although it depends on the size of the propeller. 3. As a result of the 1973 oil crisis, the 1979 energy crisis, and the resulting rise in oil prices, experimental designs using coal to fuel ships were tested in the late 1970s and early 1980s. The Australian National Lines, ANL, constructed two 74,700-ton coal burner ships called River Boyne and River Emboli 65, along with two constructed by TNT called TNT Capricornia and TNT Carpentaria and renamed Fitzroy River and Endeavour River. These ships were financially effective for the duration of their lives, and their steam engines were able to generate a shaft power of 19,000 horsepower, 14,000 kilowatts. 65 This strategy gave an interesting advantage to carriers of bauxite and similar fuel cargoes, but suffered from poor engine yield compared to higher maintenance cost and efficient modern diesels, maintenance problems due to the supply of ungraded coal, and high initial costs. 65. Hatches edit. The sliding hatch covers of Zara. A hatch or hatchway is the opening at the top of a cargo hold. The mechanical devices which allow hatches to be opened and closed are called hatch cover. In general, hatch covers are between 45% and 60% of the ship's breadth or beam and 57% to 67% of the length of the holds. 3 To efficiently load and unload cargo, hatches must be large, but large hatches present structural problems. Hull stress is concentrated around the edges of the hatches, and these areas must be reinforced. 62 Often, hatch areas are reinforced by locally increasing the scantlings or by adding structural members called stiffeners. Both of these options have the undesired effect of adding weight to the ship. As recently as the 1950s, hatches had wooden covers that would be broken apart and rebuilt by hand, rather than opened and closed. 66 Newer vessels have hydraulic-operated metal hatch covers that can often be operated by one person. 63 Hatch covers can slide forwards, backwards, or to the side, lift up or fold up. It is essential that the hatch covers be watertight. Unsealed hatches lead to accidental cargo hold flooding, which has caused many bulk carriers to sink. 67. Regulations regarding hatch covers have evolved since the investigation following the loss of the MV Derbyshire. 68 The Load Line Conference of 1966 imposed a requirement that hatch covers be able to withstand load of 1.74 tons/m2 due to seawater, and a minimum scantling of 6 mm for the tops of the hatch covers. The International Association of Classification Societies then increased this strength standard by creating its Unified Requirement S2169 in 1998. This standard requires that the pressure due to seawater be calculated as a function of freeboard and speed, especially for hatch covers located on the forward portion of the ship. 69. Hull edit. Unloaded Trillium-class dry bulk carrier at the port of Redwood City. Bulk carriers are designed to be easy to build and to store cargo efficiently. To facilitate construction, bulk carriers are built with a single hull curvature 3 also, while a bulbous bow allows a ship to move more efficiently through the water. Designers lean towards simple vertical bows on larger ships. 3 Full hulls, with large block coefficients, are almost universal, and as a result, bulk carriers are inherently slow. 3 This is offset by their efficiency. Comparing a ship's carrying capacity in terms of deadweight tonnage to its weight when empty is one way to measure its efficiency. 3 A small Handymax ship can carry 5 times its weight. 3 In larger designs, this efficiency is even more pronounced. Capesize vessels can carry more than 8 times their weight. 3 Bulk carriers have a cross-section typical of most merchant ships. The upper and lower corners of the hold are used as ballast tanks, as is the double bottom area. The corner tanks are reinforced and serve another purpose besides controlling the ship's trim. Designers choose the angle of the corner tanks to be less than that of the angle of repose of the anticipated cargoes. 13 This greatly reduces side-to-side movement, or shifting, of cargo which can endanger the ship. 13. The double bottoms are also subject to design constraints. The primary concern is that they be high enough to allow the passage of pipes and cables. These areas must also be roomy enough to allow people safe access to perform surveys and maintenance. On the other hand, concerns of excess weight and wasted volume keep the double bottoms very tight spaces. Bulk carrier hulls are made of steel, usually mild steel 70. Some manufacturers have preferred high tensile steel recently in order to reduce the tear weight. 71 However, the use of high-tensile steel for longitudinal and transverse reinforcements can reduce the hull's rigidity and resistance to corrosion. 13. Forged steel is used for some ship parts, such as the propeller shaft support. 3. Transverse partitions are made of corrugated iron, reinforced at the bottom and at connections. 3. The construction of bulk carrier hulls using a concrete steel sandwich has been investigated. 72. Double hulls have become popular in the past 10 years. 3. Designing a vessel with double sides adds primarily to its breadth, since bulk carriers are already required to have double bottoms. 73. One of the advantages of the double hull is to make room to place all the structural elements in the sides, removing them from the holds. 74. This increases the volume of the holds and simplifies their structure, which helps in loading, unloading, and cleaning. 75. Double sides also improve a ship's capacity for ballasting, which is useful when carrying light goods. The ship may have to increase its draft for stability or seakeeping reasons, which is done by adding ballast water. A recent design, called Hicon, seeks to combine the strengths of single hull and double hull construction. Short for hybrid configuration, this design doubles the forwardmost and rearmost holds and leaves the others single-hulled. 76. This approach increases the ship's solidity at key points, while reducing the overall tear weight. 77. Since the adoption of double hull has been more of an economic than a purely architectural decision, some argue that double-sided ships receive less comprehensive surveys and suffer more from hidden corrosion. 78. In spite of opposition, double hulls became a requirement for Panamax and Capesize vessels in 2005. 79. Freighters are in continual danger of breaking their backs. 80. And thus longitudinal strength is a primary architectural concern. A naval architect uses the correlation between longitudinal strength and a set of hull thicknesses called scantlings to manage problems of longitudinal strength and stresses. A ship's hull is composed of individual parts called members. 81. The set of diagram showing the wreck of Selendang AU, and the double-bottom tank leaks. In 1990 alone, 20 bulk carriers sank, taking with them 94 crewmen. In 1991, 24 bulk carriers sank, killing 154. 86. This level of loss focused attention on the safety aspects of bulk carriers, and a great deal was learned. The American Bureau of Shipping concluded that the losses were directly traceable to failure of the cargo hold structure. 30. And Lloyd's Register of Shipping added that the hull sides could not withstand the combination of local corrosion, fatigue, cracking and operational damage. 86. The accident studies showed a clear pattern. 67. Sea water enters the forward hatch, due to a large wave, a poor seal, corrosion, etc. 67. The extra water weight in hold number 1 compromises the partition to hold number 2. 67. Water enters hold number 2 and alters the trim so much that more water enters the hold. 67. With 2 holds rapidly filling with water, the bow submerges and the ship quickly sinks, leaving little time for the crew to react. 67. Previous practices had required ships to withstand the flooding of a single forward hold, but did not guard against situations where 2 holds would flood. The case where 2 after, rear, holds are flooded is no better, because the engine room is quickly flooded, leaving the ship without propulsion. If 2 holds in the middle of the ship are flooded, the stress on the hull can become so great that the ship snaps in two. Selendang AU suffered a catastrophic fracture in number 4 hold in December 2004. Other contributing factors were identified. Most shipwrecks involved ships over 20 years in age. A glut of ships of this age occurred in the 1980s, caused by an overestimate of the growth of international trade. Rather than replace them prematurely, shipping companies were compelled on cost grounds to keep their aging vessels in service. 6. Corrosion, due to a lack of maintenance, affected the seals of the hatch covers and the strength of the bulkheads which separate holds. The corrosion is difficult to detect due to the immense size of the surfaces involved. 87-88. Advanced methods of loading were not foreseen when the ships were designed. While the new processes are more efficient, loading is more difficult to control. It can take over an hour just to halt the operation, occasionally resulting in overloading the ship. These unexpected shocks, over time, can damage the hull's structural integrity. 62. Recent use of high-tensile steel allows building a structure with less material and weight while retaining similar strength. However, because it is thinner than regular steel, HT steel can corrode more easily, plus it can develop metal fatigue in choppy seas. 71. According to Lloyd's Register, a principal cause of sinkings was the attitude of ship owners, who sent ships with known problems to sea. 89. The new rules adopted in the 1997 annexes to the SALAS Convention focused on problems such as reinforcing bulkheads and the longitudinal frame, more stringent inspections, with a particular focus on corrosion, and routine import inspections. 6. The 1997 editions also required bulk carriers with restrictions, for instance, forbidden from carrying certain types of cargoes, to mark their hulls with large, easy-to-see triangles. 90. Crew Safety Edit. Launch of a free-fall lifeboat. Since December 2004, Panamax and Capesize bulk carriers have been required to carry free-fall lifeboats located on the stern, behind the deckhouse. 6. This arrangement allows the crew to abandon ship quickly in case of a catastrophic emergency. 91. One argument against the use of free-fall lifeboats is that the evacuees require some degree of physical mobility, even fitness to enter and launch the boat. 92. Also, injuries have occurred during launches, for example, in the case of incorrectly secured safety belts. 92. In December 2002, Chapter 12 of the SALAS Convention was amended to require the installation of high-level water alarms and monitoring systems on all bulk carriers. This safety measure quickly alerts watchstanders on the bridge and in the engine room in case of flooding in the hold. 6. In cases of catastrophic flooding, these detectors could speed the process of abandoning ship. Sabrina I is a modern Handymax bulk carrier. Grain bulk carrier and loading apparatus, Seattle 2010. A bulk carrier, bulk freighter, or colloquially, bulker is a merchant ship specially designed to transport unpackaged bulk cargo, such as grains, coal, ore, and cement, in its cargo holds. Since the first specialized bulk carrier was built in 1852, economic forces have led to continued development of these ships, resulting in increased size and sophistication. Today's bulk carriers are specially designed to maximize capacity, safety, efficiency, and durability. Today, bulk carriers make up 21% of the world's merchant fleets and range in size from single-hold mini bulk carriers to mammoth ore ships able to carry 400,000 metric tons of deadweight, DWT. A number of specialized designs exist. Some can unload their own cargo, some depend on port facilities for unloading, and some even package the cargo as it is loaded. Over half of all bulk carriers have Greek, Japanese, or Chinese owners, and more than a quarter are registered in Panama. South Korea is the largest single builder of bulk carriers, and 82% of these ships were built in Asia. On bulk carriers, crew are involved in operation management and maintenance of the vessel, taking care of safety, navigation, maintenance, and cargo care, in accordance with international maritime legislation. Cargo loading operations vary in complexity, and loading and discharging of cargo can take several days. Bulk carriers can be gearless, dependent upon terminal equipment, or geared, having cranes integral to the vessel. Crews can range in size from 3 people on the smallest ships to over 30 on the largest. Bulk cargo can be very dense, corrosive, or abrasive. This can present safety problems, cargo shifting, spontaneous combustion, and cargo saturation can threaten a ship. The use of ships that are old and have corrosion problems has been linked to a spate of bulk carrier sinkings in the 1990s, as have the bulk carriers' large hatchways. While important for efficient cargo handling, these allow the entry of large volumes of water in storms or if a ship is endangered by sinking. New international regulations have since been introduced to improve ship design and inspection, and to streamline the process of a crew's abandoning ship.